One last video in this lesson. Why do we always round up when we do the class width? Now, I left this off till the end because I wanted you to see the correct way to do it and to work with that correct way, and only later on come back and say, well, why is that so important? It is important. One of the rules for the building class is that the classes have to be exhaustive, meaning every single data value has to fit into a class somewhere. So let's take again the drive-through times. And let's look at what happens when we don't round up. So when we did it for 6 classes, we originally come out with 37.5. Now let's assume we don't round at all. As you can imagine, this is going to get ugly. If we start the first class at 83, and we add 37.5, well, of course, we're going to get a decimal value here. This is now going to just make our lives difficult. It's just going to wreak all sorts of havoc. Now, could we do it? Well, yeah, I suppose we could. There's no reason why not, aside from it makes the numbers kind of disgusting. Well, actually, there is a really good reason. Just bear with me for a moment. Let's continue this on. And let's go through all 6 classes. Two more. Oh, excuse me. Forgot to carry. Okay. Now I'm going to skip ahead a little bit here because the rest of this is just filling in the upper limits, and that's pretty easy until we get to the last class, and that's really where the issue is going to come in. So here's an interesting question. If this ends at 120.5, or begins at 120.5, where should the one before it end? That is an interesting question. But even still, let's check this out. Is this next one going to be big enough to get the last data value? Well, suppose for a moment we were to go on to the next class. I know we're only using 6, but this is where the beginning of the 7th class would be if we were to use one. If we added 37.5 to that, we would get 308 exactly. That means that 308 is not in this 6th class, but it is the largest data value. That means that if we stopped at 6 classes, 308 would not actually have a place to be. It would not fit into any of the classes. We would need to add on an entire extra class just to nab that last one value. So if we don't round that up, our last class will not be big enough to include all of the data values. Rounding up, as we saw, meant we did have a little bit extra. When we did round up to 38, our last class went up to 310. So it did have a couple of extra values in there that we know don't occur. And they're just not in the data set. But it's better to have a little bit extra than to come up a little bit short. So that's one reason why we always round up. Now, of course, if we got 37.5, I don't think there would be much question as to the idea that we're going to round up because it is a 0.5. The real question becomes, what if we get a whole number? Or what if we get a decimal value that looks like it should be rounded down? Well, we're actually going to run into the exact same problem, that the last class will not be big enough. If you don't round up, the last class will not be big enough. So one of the things that we looked at was, what happens if we use 7 classes? And that came out to be 32.14 ... Now, normal rounding rules, if we were rounding to the nearest whole number, which is not what we're supposed to do, but if we did that by accident, this would round down to 32. Suppose then we tried to use a class size of 32. Now remember, this is for 7 classes. And so on. I'm going to move ahead a little more quickly. You can please feel free to check any of these. Excuse me. So 7 lower limits. Again, I'm going to skip the upper limits because it's the last class I want to focus on here. If this class begins at 275, the previous one must have ended at 274. If I then add the class width to find the last upper limit, oops, remember the largest data value is 308. It doesn't fit into our 7th class. So again, by rounding down, or by not rounding at all, my classes aren't big enough. Even if our class size comes out to be a whole number. What if we use 5 classes? That was the other class size that I used before. In this case, it comes out to be exactly 45. At which point, you might think, why am I rounding at all? 45 is great. But remember, if we don't round up, if we just use the number as it is, the last class will not be big enough. So let's try this one. Let's see what happens if we do not round up. It is a whole number after all. So again, if you want to check me on these, you can. I'm going to move ahead a little bit more quickly. So again, we're going to focus on the last class here. If the last class begins at 263, then the one before it must have ended at 262. And if we add the class width of 45, we get 307. Once again, the 308 has no home. So regardless of whether we get a whole number, regardless of whether we get a decimal that otherwise should round down, or if we get a decimal that would round up anyway, each of these always goes up to the next size. The idea being that it's always better to use a slightly too big class width and have a few extra values in the last class that we know we'll never see, rather than leaving out one of the data values. So we always go up no matter what. Now, here's another interesting thing while we're at it. Why do we add the class width going down like that? Why don't we add the class width to the lower limit to get the upper limit? Well, we're going to actually use a smaller set here. Let's keep it simple. Let's suppose we have a class width of 5, and let's suppose our lowest data value is 1. Give us some nice friendly numbers to work with. Now, as I instructed you, that means the first class should begin at 1, and the class width, we add the class width to the lower limit to get the next lower limit, and so on and so forth. So one of the questions I'm asked most often is, why don't we add 1 plus 5 and go to 6 that way? Well, actually it has to do with how many values are in the class. Now, this explanation works best with integers, with whole numbers, but if you're careful, it can work on decimals as well. The class 1 to 5 actually includes the values 1, 2, 3, 4, and 5. There are literally 5 numbers in that class. The next class, 6 to 10, includes 6, 7, 8, 9, and 10. Once again, literally 5 values. So one way to interpret the class width, at least again with integer data, is that the class width deals with the actual number of numbers in that class. If I went from 1 to 6, then the 6 would be up here and I wouldn't have a class width of 5. I'd have 6 items in each class. So to have a class width of 5, I need to have 5 in each thing. And that means the next class starts after that. 1 plus 6 is, or 1 plus 5 is 6. This is actually kind of neat. It also allows you to see the relationship I was talking about with the midpoints, how corresponding values in consecutive classes differ by the class width. 1 plus 5 is 6. If we take the second number in each class, 2 plus 5 is 7. If we take the third, 3 plus 5 is 8. If we take the fourth, 4 plus 5 is 9. If we take the fifth, 5 plus 5 is 10. And that's why the midpoints follow this same rule. But this is the reason why we add the class width going down. It seems a little odd at first, but when you actually look at how many numbers are in each class, it does kind of make sense. Obviously, I didn't want to use the drive-through data for this because with a class size of 38, that's a very long list of numbers. So I used different numbers to kind of make it more manageable to write and easier to grasp the concept. But that is the idea of the class width. So again, we got some of the different things here about why it's so important to do things a certain way. We saw why we always round up in building our class and determining our class width so that we build our classes properly. And we got a chance to see why we add the class width going down instead of going side to side.